Today we're going to be using the rational root theorem. Now this is a way that we can use to find all the zeros or roots of a polynomial. Now, how the rational root theorem works basically is this. If there is a rational root, it's going to be in the form of plus or minus p over q, where p are the factors of, where p is a, or the factors of the constant term, and q are the factors of the leading coefficient. I don't know what that means. Anyway, so where p is the factor of the constant term, so this 6, that's our p, and the constant, that's our constant, and the q is the leading coefficient, which here is a 1. So what I'm going to do is I'm going to list out all the p's and q's. So p is 6, q is 1, and I list out their factors. The factors of 6 being 1, 2, 3, and 6, and q just being 1. I'm going to list out my possibles by putting in the form plus or minus p over q. So how that works is I'm going to take each p, put it over 1. So 1 divided by 1, 1. 2 divided by 1, 2. 3 divided by 1, 3. 6 divided by 1, 6. So at most we have 4 of these, but double it, you have 8 bad guesses. Now we need 4 of them, which means if there are going to be rational roots, 4 of these should work for us. Maybe. We'll see. That's what we're trying to solve. We use synthetic division to determine which roots are actually roots first. So to do that, I'm just going to divide. Now, first of all, I'm going to pick 1. Now, I'm using synthetic division because of the remainder theorem. The remainder theorem says if we divide and the remainder is 0, we have a root. So if I use 1, I get 1, negative 1, 1, negative 3, negative 6. And I divide 1, 1, that becomes 0, 0, 1, 1, negative 2, becomes negative 2, negative 8. So 1 is not a root for us because it's not 0. So next I try negative 1. This is really a guess and check method. 1, negative 1, 1, negative 3, negative 6. If I try the 1, 1, negative 1 becomes negative 2, which becomes 2, and we get 3. Negative 3, and I get negative 6. Oh, multiply here, I get positive 6. Now remainder is 0. So I have a root. So I know I'm going to have 4 of them, so I'm just going to go ahead and list them all out. X equals, I got negative 1, and I need 3 more. Now I had 1 that works, negative 1 that works. So let me try another one, 2. Now when I try the 2, don't plug it into the original function, plug it into your reduced polynomial. Because that's going to be keep reducing it. Because I have a cubic, sorry, this is a 4th power, this is our cubic. So we get 1, negative 2, 3, negative 6. And I do the same thing. 1 becomes 2, 0, 0, 3, 6, 0. Boom! It works as well. So 2 also works. Nice. And now, since I have 2 of them, what am I left with? A quadratic. I get the function x squared plus 3 equals 0. And now I have to solve for this one. Now there's many ways I can solve for this. This one's not too bad to do. One, I cannot complete the square on this one. Or, sorry, I cannot just factor this one because it's not a difference of squares. So I'm going to solve it using the old algebra 2 way. Subtract the 3. If I take the square root, I get plus or minus the square root of negative 3, which is plus or minus I root 3. So the other 2 are completely imaginary. So I get I root 3 and negative I root 3. And those are our 4 roots. 2 are real, so this graph will cross the x-axis twice. And there's that one. And this is the ultimate goal, which we're going to talk about in a couple of days. How do we graph this one? And that's going to be the goal in a few days. All right, the next one, number 2. Let's try this one. Now this one has a degree of 3. So we're going to have 3 answers for this one. So let's go ahead and start this one. First going to find out what are my possible roots. So on my possible roots, I'm going to get my p or q. P is 5. Don't worry about the negative, so it's just 1 and 5. Q is 2, which gives me 1 and 2. So my possibles, plus or minus p over q, are 1 over 1, which is 1, 5 over 1, which is 5, but I also get 1 over 2 and 5 over 2. Oh, yuck. But what's nice is if we find 1, we reduce it to a quadratic. So let's start. Don't start with the fractions unless you want to be a hero. Start over here with like a 1. So I'll pick 1. I get 2, negative 5, 12, negative 5. Going down the 2, I get 2, negative 3. Negative 3 becomes 9, and 9 doesn't work. So I try negative 1. Hopefully that works. 2, negative 5, 12, negative 5. 2, negative 2 becomes negative 7. 7, oh man, which is 19, which is negative 19, and that also doesn't work. Let me just check that one again. 2, negative 2, negative 7. Oh man, that doesn't work. So I gotta try 1/2 now. 1/2, 2, negative 5, 12, negative 5, and I just keep going. This becomes 2, which becomes 1, which becomes negative 4, which becomes negative 2, which becomes 10, which becomes 5, which is 0. So I got one of my roots, 1/2. So I get x equals 1/2. I need 2 more, but we're in luck. This is quadratic, so I get 2x squared minus 4x plus 10 equals 0, and that's what I want to solve. Use a little bit of algebra. I get x squared, divide everything by 2, minus 2x plus 5 equals 0. And right away, I know I cannot solve this one by hand. The only way to solve this one is by using the quadratic formula. Okay? So I'm going to use the quadratic formula for this one. And we all know how that goes. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Very good. X equals 2 plus or minus the square root of, this is 4 minus 20. That's negative 16 over 2. So again, we have an imaginary root. X equals 2 plus or minus I 4 over 2. And you can divide, you get 1 plus or minus 2i. Those are your other two roots. 1 plus 2i, 1 minus 2i. Now notice, imaginary roots always have to occur in conjugate pairs. They have to. That's the way they work. Now, we can use this to factor completely. So if you need to, go down, go try these again, slow it down if you need to. Then number 3, we're asked to factor the following completely. So to factor this completely, we're actually going to look for roots. So I look at my P and Q. So my P comes from 1, which is just 1. Q is also 1, which is just 1. So my only possible rational root is either plus or minus 1. And this is going to be a fun one. We need 5 of them. Now, to get this down to a quadratic, though, we need to find 3 roots that are the same. So let's see here. Let's try 1 first. See if 1 works. 1, negative 3, 4, negative 4, 3, negative 1. Bring down the 1. I get 1, negative 2, which becomes 2. 2 becomes negative 2. Negative 2, which becomes 1, 1, which is 0. All right, so one of my roots is x equals 1. Now, I can try negative 1, but I know I have to have multiple roots here because of the 5 right here. So what I'm going to do is I'm going to try 1 one more time. Now, watch what I'm going to do. I'm not going to rewrite it. I can actually try it right here since I got one that worked. I use my old one, my reduced formula. We get 1, 1, negative 1. Negative 1, 1, 1, negative 1, negative 1, 0. Boom! I got another root. Also 1. So far that's M2. Now, but more importantly, this was originally a fifth, a fourth, now we're at a cubic. If I find 1 more, I got a quadratic. So you know what I'm going to do? I'm going to try 1 more time. We get 1, 1, 0, 0, 1, 1, 0. It works again. So I get x equals 1 more time. And now I'm left with this quadratic right here. X squared plus 1 equals 0. Now, I don't have to find the roots for this one because I didn't want to find the roots. I wanted to find the factors. So my roots are going to be x equals 1 3 times, right? Remember, that's M3. So if I want to write these become x minus 1 cubed. times my remaining factor, x squared plus 1. And that's how we factor it completely. You don't have to solve for this one because we're not looking for the zeros, we're looking for the factors. So what I would like you guys to try to do is number 4 on your own, okay? All right. And let's go and take a look over here. Same way. We'll go over it tomorrow in class. Right. Now, on the back, let's talk a little bit more about the imaginary solutions. So let's go ahead and sketch this graph right here. X squared plus 16. We know what it looks like. It's a parabola, right? Now, what do we notice? It is a parabola. Does it cross the x-axis? No, it does not cross the x-axis. So therefore, this should have no real solutions. And that's what we call it right there. No real solutions. So how do we solve for imaginary roots? Very easy, and we've already talked about this. Set it equal to 0. Sometimes you may have to use the quadratic formula. And if I solve this one, we get x squared equals negative 16. When you try to take the square root, that's when you notice the imaginary. So we get x equals plus or minus 4i. We get our imaginary roots. So let's solve the following. These are going to be imaginary roots or complex roots. So the one thing to remember is that when you're solving these, you should get 2 answers, a conjugate pair. Now this one right here, it's not as easy to solve as this x squared plus 16. We actually have to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times 1 times 2 all over 2 times 1. So we get x equals negative 5 plus or minus the square root of, that's 17 over 2. 25 minus 8 is 17. Now, we do get 2 answers. These are our conjugate pairs. So you get negative 5 plus the square root of 17 over 2 and negative 5 minus the square root of 17 over 2. Conjugate pairs. All right, try number 6 and go on to part 2.